So this is the last page of the grouping lesson, and we're just going to use this page to review the previous types of factoring so we don't forget them. So first off, I noticed about these 4 factoring problems that I don't have 4 terms in any of them, so I'm probably not going to do the grouping we just learned. Looking at the first one, I have a trinomial. I don't have a GCF, so I'm going to go directly to looking for the factor pairs that work for adding and multiplying. So the factors of negative 27 add up to negative 6 are negative 9 and positive 3. For the next one, I only have 2 terms, and I do have a GCF, so I'm going to take that out first. And I do see that after that, I have the difference of perfect squares. I never try to go from here to here in one step. You really want to show that middle step, and each type of factoring show a step for. Letter C, I do have a GCF again, so I take out a negative 6. And that is going to switch terms here. So when I take out a negative 6, I get a positive 5x and a negative 6. So be careful with 6, right? Sometimes we are close but not quite right. So my numbers that are going to work are negative 6 and positive 1. If I use 2 and 3, it would not work out correctly. The last one is something a little bit new. So this is difference of perfect squares because x to the 4th is a perfect square. So I'm going to write down x squared plus 4 and x squared minus 4. And when I look at this word difference, we know that means subtraction. And in class, we've talked about why it doesn't work for adding. So that's something that you could ask about if you don't remember. So this one has adding. It has to stay, right? This one is another difference of perfect squares that came from factoring, right, my first factoring step. So I do have to go one step further. So in special situations, basically that can happen, and we always want to check on the difference of perfect squares. The last little thing is just something to be careful of when grouping. It says, consider the expression 2x cubed plus 10x squared plus 7x plus 21. So there's an error with factoring it, and we want to explain it, and how can we tell the factoring is incorrect? So we're going to first explain the error. So looking at this, they did grouping, and they did that grouping correctly. So this is a correct step right here. Now, they know they're probably supposed to be grouping. This binomial does not match, so we are not able to just put it together and combine it. That binomial has to be exactly the same, and then we would bring it to the front. So x plus 5 and x plus 3 are not the same factor. So the second step is incorrect. So the second question we're going to answer is, how can we tell the factoring is incorrect? Now, one way we can tell is just looking through it and finding errors, like kind of looking at each line. Remember, the second way I can check is to distribute and go in the other direction. So if I distribute this, 2x squared times 2x, already we have an issue. We get 4x cubed plus 16x squared. Second set of distributions, I get 14x plus 56. So this, while the right number of terms is not the same 4-term polynomial as that, so we can tell it's incorrect by multiplying it. So to answer that question, we can multiply the factors to see if they are equal to the original expression. I'm going to abbreviate that there for expression.